Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2195, indicates that the rear air fuel AF sensor on bank 1, sensor 1, is reporting a signal that is stuck lean. This means that the sensor is detected as giving a reading indicating a higher oxygen concentration in the exhaust than what is normal, suggesting that not enough fuel is being introduced into the combustion chamber. Additionally, DTC P2197 represents the front AF sensor on bank 2. Sensor 1, with similar lean conditions. The AF sensors are crucial components in maintaining optimal fuel-to-air ratios for efficient combustion, located in the exhaust stream before the catalytic converter. Proper function of these sensors is vital for vehicle performance and emissions compliance. These DTCs can be triggered by factors such as sensor malfunction, poor fuel conditions, or exhaust system leaks. In the context of DTC P2195, the rear AF sensor, bank 1, sensor 1, is situated in the exhaust manifold, monitoring the amount of oxygen in the exhaust gases emitted by the engine. Similarly, the front AF sensor, bank 2, sensor 1, serves a parallel function but is located ahead in the exhaust system on a different bank, measuring the air-fuel mixture to optimize engine performance. These sensors play a crucial role in feedback for the powertrain control module, PCM, to adjust fuel delivery and air intake. Failure of either sensor can lead to poor fuel efficiency, rough engine performance, and higher emissions. The location of these AF sensors is strategically chosen to ensure real-time analysis of exhaust gases as they pass through, providing vital data for air-fuel adjustments necessary for efficient combustion. There are several possible causes for DTC P2195 and P2197. One common issue is a dirty mass airflow MAF sensor, which can disrupt airflow measurements, leading to incorrect fuel adjustments by the PCM. The MAF sensor must be clean and free of debris for optimal operation. Another potential cause is a loose or disconnected AF sensor, which can fail to provide accurate readings to the PCM, resulting in lean conditions. Problems can arise from the PCM itself. If it is not functioning correctly, it may misinterpret data from the sensors, leading to triggered DTCs. It's also important to evaluate the entire exhaust system for leaks, which may affect the readings of the AF sensors, contributing to their detection as stuck lean. Common symptoms associated with DTC P2195 and P2197 include the check engine light illuminated on the dashboard. This is often the first indication that a trouble code has been triggered and requires attention. Drivers may also experience poor fuel economy as the engine struggles to find the right air-fuel ratio due to faulty sensor information. Additionally, rough engine performance or hesitation during acceleration can occur, which may be directly linked to the vehicle running lean. If the vehicle's PCM is unable to appropriately adjust the fuel flow due to erroneous data from the AF sensors, these symptoms can become more pronounced. Noteworthy is that fluctuations or irregular engine behavior might also point toward underlying issues in the fuel system or exhaust integrity. The first troubleshooting step for addressing DTC P2195 and P2197 involves a visual inspection of the mass airflow MAF sensor and intake air temperature IAT sensor. To perform this, you need to carefully remove the MAF IAT sensor from its housing. Once removed, check for any dirt or debris that may obstruct airflow and affect readings. If the sensor is found to be dirty, it will need to be cleaned thoroughly. Or, if the buildup is substantial, replacement may be necessary. A clean MAF IAT sensor ensures accurate airflow readings, which is crucial for the engine's optimal fuel mixture adjustments. If the MAF IAT sensor is clean, you will proceed to the next step in troubleshooting. The second step in the troubleshooting process focuses on the AF sensor installations. It is important to inspect the AF sensor, especially sensor 1, to ensure that it is correctly installed and connected. Sometimes, sensors may become loose or disconnected from the three-way catalytic converter, WHWC, leading to erroneous signals of a lean condition. If the AF sensor is indeed found to be loose or disconnected, it should be properly reinstalled to ensure firm connectivity. A securely installed sensor can significantly improve the accuracy of fuel mixture readings sent to the PCM. If the installation check returns no issues, you would continue to the third troubleshooting step to further analyze potential problems. Moving on to the third troubleshooting step, the procedure begins with turning the vehicle's ignition to the on position. Following that, the DTC should be cleared using the Honda Diagnostic System, HDS. Clearing the DTC is essential as it resets the diagnostic memory, allowing for fresh data to be captured. Next, start the engine and maintain a steady engine speed of 3,000 revolutions per minute, RPM, without any load by placing the vehicle in either park, P, or neutral, N. Keeping the engine at this speed is crucial until the radiator fan engages. It's during this period that the PCM reevaluates the status of emission sensors. Once this is completed, check for any pending or confirmed DTCs with the HDS once again to assess if any concerns have persisted. In the fourth troubleshooting step, the diagnostic procedure entails checking for the presence of the DTC P2195 and/or P2197 after carrying out the previous steps. If one or both of these codes reappear, it's critical to investigate potential issues related to the AF sensor connections and wiring, or the PCM itself. Ensuring that there are no poor connections or loose terminals is essential to the functionality of the sensors. If the DTCs are confirmed, the next course of action involves substituting in a known good PCM to determine if the original PCM is faulty. If swapping in the new PCM resolves the DTCs, it indicates that the original PCM should be replaced to restore proper function. If the DTCs do not disappear, further investigation into intermittent failures must be conducted. Once all troubleshooting steps and repairs have been completed, it is crucial to verify that the necessary corrections have been effective. Begin by checking all repairs that were executed against the vehicle's initial condition. Following this, the next step is to rescan the vehicle using the HDS for any existing DTCs. Performing this check will help in confirming that all codes related to DTC P2195 and P2197 are cleared and have not returned. Finally, a test drive is essential to assess the vehicle's performance under typical driving conditions. It allows for observation of engine behavior post-repair and ensures that no warning lights reappear, confirming that the AF sensors are now functioning correctly and reliably. To prevent future occurrences of DTC P2195 and P2197, regular preventive maintenance should be applied to critical components like AF sensors and MAF sensors. It is beneficial to include a routine inspection of the AF sensors during standard service intervals to catch any issues early on. Periodic cleaning of the MAF sensor is advisable as this sensor can accumulate dirt over time, leading to performance degradation. Inspecting the exhaust system for any leaks or corrosion is equally important, since exhaust leaks can impact sensor readings and cause erratic engine performance. Keeping an eye on these preventive measures not only prolongs the life of the sensors, but also ensures that the vehicle maintains its fuel efficiency and reduces harmful emissions. In conclusion, understanding the role that AF sensors play in maintaining proper engine function is essential for effective vehicle performance. The DTCs P2195 and P2197 highlight the significance of these sensors in monitoring and balancing air and fuel ratios. Timely and precise diagnosis of these codes is crucial for addressing underlying issues swiftly and efficiently. Routine inspections and preventive maintenance can avert future complications and help maintain optimal fuel efficiency, ensuring the vehicle performs at its best. By adhering to these guidelines, Honda Pilot owners can achieve reliability and longevity from their vehicle, while reducing harmful emissions and maximizing performance. Please like and subscribe to the channel. See you next time.